Internationally, there is a competition and collaboration in the field of quantum computing. Companies and research institutions across the world, including China, the United States, and Japan, are actively developing quantum technologies, exploring applications in various fields like material design and pharmaceutical development. In a more general sense, quantum computing fundamentally differs from classical computing in the way it processes information. Classical computers use bits that are either in the state of 0 or 1, while quantum computers use quantum bits, or qubits, which can exist in a state of superposition, representing both 0 and 1 simultaneously. This unique property allows quantum computers to process a vast number of possibilities simultaneously, making them potentially much better and more powerful for certain types of calculations, such as factoring large numbers, which is a key aspect of encryption like RSA. So, what is quantum superposition, and how does that affect quantum computing? Quantum superposition is like having a coin that can spin in the air while it's spinning. It's not just heads or tails, it's kind of both at the same time. In quantum computing, this is similar to what happens with qubits. Unlike regular computer bits that are either 0 or 1 or heads or tails, qubits can be in a state where they're kind of 0 and 1 at the same time, and this is the idea behind superposition. The advantages of having superposition is that quantum computers can handle a large range of possibilities at once. For instance, if you are trying to solve a really complicated puzzle, a classical computer will try one solution at a time, but a quantum computer can try many solutions simultaneously. This makes quantum computers potentially very powerful for certain types of problems, like cracking codes or simulating molecules for drug development. However, there are limitations to the idea of superposition state. It is very delicate and it can be easily disturbed by things like temperature changes or even tiny vibrations. This disturbance can cause qubits to lose their quantum properties, a problem known as decoherence. Also, quantum computers are not necessarily better for all types of tasks. For many everyday calculations, classical computers are still more efficient. As of 2023, significant advances in quantum computing can already be seen. For instance, IBM's quantum computers. IBM is a leader in quantum computing research, unveiled an Osprey quantum computer in November 2022, which boasts 433 qubits. This was a significant leap from its previous 127 qubit Eagle quantum computer. IBM has a roadmap to develop quantum computers with even more qubits, targeting a 1,121 qubits in 2003 called Condor QC and 1,386 qubits in 2024 called Flamingo QC. The company aims to reach 4,000 qubits by 2025 with the expectation that full-scale commercial quantum computing will likely begin around 2027. Another large development is quantum as service. Big tech firms are increasingly offering quantum as service, with Microsoft Azure Quantum being a notable example. This service provides users with access to hardware from other companies such as IonQ, Toshiba, and Honeywell's Quantum. The quantum as service market is expected to grow as more companies invest in quantum technologies. Furthermore, several large companies like JP Morgan, Volkswagen, and Lockheed Martin are investing in quantum infrastructure, preparing for the widespread adoption of quantum computers. They aim to leverage quantum computing for applications in financial modeling, process optimization, cybersecurity, and military research and development. The quantum computing market is also experiencing rapid growth and is projected to continue expanding significantly in the coming years. As of 2022, the global quantum computing market has a value of approximately $717 million. This market size is projected to grow to $928 million in 2023 and expected to reach around $6.53 billion by 2030, with a compound annual growth rate of 32.1%. Regionally speaking, North America currently dominates the global quantum computing market, largely due to investments in support of development of quantum computing technologies by the government. The market in Europe also is showing substantial growth, driven by growing adoption of cloud computing in various industries and ongoing research and development in quantum computing. Furthermore, in Asia and Pacific, countries like China and Japan are actively investing in quantum computing, with China making significant advancements and investments in this field. So, you might be asking, is it possible to purchase a quantum computer in 2023? The answer is yes, but they're primarily targeting towards research institutions, large corporations, and government bodies due to the high costs and complexity. As of today, quantum computing is still not widely available for the general public. For those who are interested in purchasing a quantum computer, direct contacts with companies like IBM, Microsoft, Rigetti Computing, D-Wave, or Google is advisable. These companies offer access to their quantum computing resources through the cloud, allowing users to utilize quantum computing power without owning physical hardware. The cost of using these services varies, typically ranging from a few dollars to several $1,000s per hour, depending on the amount of time and resources involved. Regarding the pricing of quantum computers, it's challenging to pinpoint an exact figure due to rapid advancements in technology and the variety of systems available. However, in 2017, the D-Wave 2000 qubit quantum computer was quoted at around $15 million, although this price might have changed due to inflation and advancements. The cost of quantum computing systems, like those from IBM, are generally in the tens of millions, often as part of a full service contract spanning several years. For more accessible options, there are companies like Shenzhen's SpinQ Technology in China, which has unveiled plans to sell a desktop quantum computer for less than $5,000. This device is aimed at educational institutions and is less powerful than the commercial quantum computers used for research and development, being capable of just processing 2 qubits. The price of operating these quantum computers is not cheap either, primarily due to the specialized infrastructure and technological requirements needed to maintain and run these systems. First of all, we have cooling systems. Quantum computers often require extremely low temperatures to operate effectively, especially those based on superconducting qubits. Maintaining such temperatures typically involves the use of dilution refrigerators and liquid helium, which can be expensive to operate continuously. Another cost that we need to consider is energy consumption. The energy required to maintain the operational conditions of a quantum computer, including the cooling system, contributes to the operating costs. The precise energy consumption can vary based on the type of quantum computer and the amount of usage. The last major operating cost of maintaining a quantum computer is the technical support required. Quantum computers are complex machines that require regular maintenance and technical support from highly specialized personnel in quantum computing. These involve both hardware maintenance and software updates. If you are interested in investing in quantum computing, there are a few options that you can consider. First is buying stocks from major companies like IBM, Microsoft, and Alphabet, which are key players in the quantum computing market. If you are more interested in investing in companies that are focused solely on quantum computing, you can consider investing in companies like IonQ and Rigetti Computing, which are focused specifically on quantum computing technologies. Finally, for those who prefer a more diversified approach to investing in quantum computing technologies, you can consider investing in Defiance Quantum ETF, or QTUM. The Defiance Quantum ETF offers a broader exposure to quantum computing sector by encompassing multiple stocks from semiconductors and software industries involved in quantum computing ventures.